good evening, everyone, or good day, probably to someone. Um, we're very happy to invite you here, and it's the derivative space code Anatomy of a Successful Audit, and we're gonna discuss the audit IPOR had with Ackee blockchain. First of all, a few words about Ackee blockchain. We are white hat hackers and smart contract blockchain auditors on Solana and Ethereum. And I'm very happy to introduce my colleagues here, Lukasz and Miro. You guys say hello.
Hey guys.
Hello everyone.
And now passing mic to IPOR. Vlad.
I think there's like a 5-second lag, so let's give Lukasz a few more seconds.
He's muted.
Okay, so Vlad, probably you can say a few words about IPOR in the meantime.
I would give the word to Darren. He is the pro here.
Yeah, let's try it. 1 second.
Yeah, can you hear me now?
Yeah.
Yes.
Yeah.
There's about a 30-second lag.
Oh, 30 seconds too much.
Okay, Lukasz, you're going to have to talk a very long time and then stop. It's about a 30-second lag.
Oh, 30 seconds too much.
So,
Okay,
okay,
you're going to have to talk a very long time and then stop.
let's try that. You have questions, you give me a couple seconds, there'll be a couple seconds of silence, and I will answer. I promise. I'm listening.
You have questions, you give me a couple seconds.
Okay, so I guess the question was just, guys, could you please introduce yourselves and say a few words about IPOR?
Yeah, so my name is Lucas, and I'm working as a head of product for IPOR Labs. And well, I kind of sit in the middle between development and the business and all the requirements. So I work very closely with engineers. And in this case, I also work with Ackee team. I also work on the product. So I write documentation and I design the product along with Dimitar from our team and Darren and our engineers. So you may say I kind of sit in the middle of this whole adventure from an engineering perspective, at least.
Amazing. So let's talk about the audit itself. So I'm now asking Ackee guys, can you say a few words about how the audit was going? How many days did it take? Like some general information.
Okay, I think I can start. We audited like liquidity mining. It's like the mining staking part of the IPOR protocol. I think audit was performed around like October, November. I think like 3-4 weeks, if I guess correctly. And This audit like went pretty smooth. Like the first good part of the audit was the like overall experience and communication with the IPOR team. We accumulated around 20 issues, but none of the issues was like the direct threat for the IPOR protocol. So engineering team of the IPOR obviously did a great job with the development. In this audit, we pay like special attention for arithmetic operation because it's basically the crucial part of every DeFi project, and especially if there is some staking, there is a lot of math and there is a lot of calculation how to distribute rewards. So it was like the main focus for us during the audit. Yes, it's like this short introduction of the audit.
Great, thank you. And so my second question is, why can you say that this audit was successful? What in general makes an audit successful? Ackee guys, you answer first, and then I'll ask IPOR guys to answer like what they think about this.
Okay, so hello everyone. I will take this question. So for me, a successful audit consists of multiple parts, and each of them has to go well to overall have a good audit. So the first part for me is the pre-audit part, and this part is it's focused on the development team. We need from the team to have a clear and effective communication of their needs, and we need them to provide documentation. Any available study materials are very convenient. For example, IPOR guys provided a very neat flow diagram, which allowed us to understand the protocol faster. Of course, a very important part of the pre-audit is having a sufficient testing suite. And we have to say that we were really impressed with the testing infrastructure that IPOR guys developed over the development process. Another part of the pre-audit process is like having the basic security done. That's usage of static analyzers like Slither, and that's also something that IPOR had covered. So I would say that the pre-audit part was pretty good. So that's the first checkbox. Another thing that I require or that's part of the audit, it's our actual manual review, and like what consists of like the actual audit from the auditing company perspective. So we usually start with static analyzers to get the general feeling of the code base, whether there's some like low-hanging fruit, etc. Then we dive deep into the documentation, into the study materials, and we try to distill like all the information about the protocol so that we can go into deep analysis. And thanks to the good pre-audit part, we were able to do this. Then, of course, there's the manual hacking. We go line by line, try to find like edge cases, try to find creative exploits. Yeah, we were able to do this audit with 2 auditors, which is always good and also helps to have a successful audit because we can validate each other's suspicions, have great questions, conversations, etc. Another important part of the like auditing part is testing, and that's testing from the auditing company perspective. So we don't focus like on the general like logic of the code base that should be covered by the unit tests, and it was. We focus more on the edge cases, and in case of this audit, we actually focused on the test part a lot, because the IPOR guys used the APTK floating point arithmetic library, which is very hard to audit manually in like a short time horizon. So we decided to implement like differential fuzz tests, and Lukáš will have to say more about this a little bit later. But all of those steps like have to be taken to consider the audit successful. Then, of course, we have the number of findings, their severity. That's something that Lukáš already talked about, and overall the confidence of the auditors about the output, which we can say that we spent a lot of time. We focused on like every single line, every single comment, everything. We discussed the protocol deeply with the development team, and we are very satisfied about this part. And this is like, after we finish this, the audit doesn't actually end. We have to communicate the issues clearly with the development team and explain our findings and make sure that they understand it so they can implement fixes for them. For this, we have a special readout call where we gather with the development team and discuss all the issues. So this checkbox, we also have this checked out. And lastly, the development team has to focus on fixing the issues that we provided and send back to us the fixes such that we can validate them and ensure that the final form of the protocol is secure. And if we go through this whole pipeline and check all the checkboxes, then I would consider this a successful audit. And in case of IPOR, this everything, all of those steps were taken. So I hope that I answered this successfully, and that's all from my part. Yeah.
Yeah, you sure did. Thank you. So, IPOR guys, and what's your take on successful audit?
Well, from our perspective, I would say that there's two things in order for the audit to be successful. And the first one is, you need to prepare well. We just heard from your side that, how the preparation is important. And I'll speak from experience that we had, because we had already a couple of audits. And I would say probably one of the most important things is, for at least from our perspective, open and direct communication. And a word about that. What do I mean by that? So what I mean is, as a developers, we want to have a very good feedback loop with the auditor. This is crucial to save time, and ending up with a better result of audit. Because we as a team, we want to get the feedback about the findings, what the auditor can find, as soon as you discover the issues, so we can start analyzing the impact and coming up with solutions. Because we need to remember that one issue here and there might have a trickle-down effect somewhere else. We're designing a complex system. Things should work together. So we always get a little bit of this anxiety, what will the auditor find, and how much time we will have to fix it properly, with the tests and like not just patch it, but like you really understand, what the consequences are. So, like from our perspective, successful audit has that communication. So we don't wait until the very end to get to know, the results, but we have this back and forth, and that kind of, gets me to a second thing, is that we don't stop working. When we hand over the code, we kind of paranoid. So we always try to almost like run our own internal audit in parallel to auditors. So whenever we find something, and it happens that we could find that we would find something, we would always report to auditors that we work with. So like we want to have that dialogue going on, and when we have the dialogue, there's questions. And I would say that the questions are probably the best token, like from a perspective of audited team or audited product. If the auditor comes and asks good questions, and I mean not like a superficial questions, but like really like questions that make us like that like make us think that you guys really understand what we're trying to build, that induces a lot of confidence in the team, in the engineering team, that we work with an auditor that really understands what we're building. And there was several occasions. I was scrolling back the history of the chat that we had, when we had very good questions coming from the Ackee team. So I remember, Miroslav, he was asking questions about, why we do things in a certain way, or like what's the reason for this and that. And we are like, okay, cool. They understand what we do. Like, it's not just the code they trying to understand, but they try to understand the logic behind it. Like, what are we trying to solve for? And we were like, we high-fived in after those questions came, and we could answer them, and it was very stimulating to answer those questions. So I would say the successful audit starts with those questions and understanding what we're trying to build, because then auditing code, I would say it's much easier. I guess this is what you guys also said. Like, we understand what we're building, then the next step is really looking into the code. But we want to know that you guys know what we're doing, and I would say we had that in this audit, which was fantastic. We loved that experience.
Thank you. And I believe that this is much because you were really well prepared for the audit. So my next question is, how did you prepare and how long did it take you to prepare for the audit?
Yeah, so the preparation really starts when we start writing the code. So we know the audit is going to come. But like the whole process of building this really starts with documentation. So you see, you guys talk that we need to prepare documentation for the audit, but what we do at IPOR, we actually start with documentation before we write code. Because what we're building is fairly complex, and it's like the liquidity mining is one thing, but we have also other contracts that we have audited, and they all work together. They're designed to be parts of a bigger whole. So we start with the documentation, and this is our chance to really iron out things that have to be ironed out, like before we actually go into the code. So we spend a lot of time in Excel and Jupyter notebooks, and we model things out. And once once we have that, once we're happy with the documentation, with the solution, only then we go into the development. And when we do develop, we write lots of code, lots of tests. So this is what you guys pointed out. There's a lot of tests, and we don't try to save time on tests. The software is already complex enough that we need to abstract that complexity, and tests is a way to manage complex code base. So we use tests not only to ensure that we can that the code does what it's supposed to do, but we also use tests to aid the development process and abstract that complexity. And at the end of the day, we have the test suite that we can use, obviously, to test the software. So we write code, we write tests, and at the end, we actually run some sort of internal audit. So we use the static analysis tools that some like the auditors would use. We run them in house, try to solve all the issues that they produce or they discover. Then of course we refactor, optimize. We try to optimize for gas as much as we can. And we also have internal reviews, internal audits. And then we say, okay, now we're ready for the audit. What we're trying to do is really grab all the low-hanging fruit so that when it comes to the audit, the auditor doesn't need to focus on trivial things, like, reentrancy here and there, but rather focus on the difficult things. Because when we work with auditor, like we want support on the hard stuff. Like the easy stuff is easy. When we work with somebody like Ackee, we find you guys to be very good at the math, and that was very important to us. So have a very good academic background. Your auditors. And so we can work with them because they can help us with complex issues. Okay, easy stuff is less interesting, and you did so. Like finding this issue with the library, which we had a lot of anxiety about because we took the library. We know that everybody's using it, but when we went into the audit, we told you guys, hey, listen, please help us with this library because this is probably better if you can have a second look at it, because we do our research, but it would be great if you can look at it as well. And you found that issue with lack of precision, which in our case was okay, but we were very glad you found it. So that was another point that you guys scored. That made us even more confident in your work. On to you.
Thank you. So let's just remember, and could you please guide us through the flow of the audit? So how was it going? A methodology, like where you started, where you finished. So I guess the first question goes to Ackee team.
Yes, like Mirror, the second auditor, he basically said that in his long answer. But our flow, like the first part in the audit, is obviously documentation, as it was mentioned many times already, and I'm glad we can agree with the IPOR team that it's very crucial part of the audit, because it has many benefits. It's obviously it's more easy for auditors if you have a good documentation to understand the protocol. But if you have a great documentation, you can understand it more faster, and faster you understand it, the faster you can really start looking for some issues. And if you understand it on this the best way, the best you can, and focus on real complex issue. Because if you were just looking at the functions one by one and looking for some patterns like reentrancies and similar stuff, you usually are not able to find some real bug in deep logic. So that's also why it's necessary. So if we start with the documentation and after we understand it pretty clearly, we go through the code line by line, as has been said. We run some automated tests like Slither provide. We also have our own tool Vogue, which also runs some automated tests, so it can help us with some findings, but usually it's a false positive or it's nothing too critical. But I want to mention like important part, and it's if you do some local deployment of the protocol. Uh, because if you really deploy it and like make your hands a little bit dirty and you understand how things truly work, because like looking at the code is one thing, but really like use it is the second thing. And if we have the code deployed in our like testing framework, we can perform like the tests and we can implement tests in the way like we want it. Mira also like said that engineering team of the protocol like should provide some unit tests, but we focus on the things like we want to focus. And the like the best way we think is to like write some fast tests, which means like if we can randomize input as much as possible, there is a higher chance that we will find some real edge case scenario that we like never think about. And it can, especially for like some mathematics formulas, it's very strong and powerful tool for like smart contract auditing, to writing these fastest. And if we write these tests and we find like some, if something is reverting, we need to like start debugging the transaction. For debugging, we also use like, we used Brownie before. Now we also use our own tool. So you need to debug the like the call trace of all the like transfers and function calls, and you need to find if the issue is really in the smart contract or your tests has like something wrong inside. So we debugging, and we also use sometimes like low level debugging. For example, like Foundry provide pretty good tool. If you have some like tricky function, you can use these debuggers and you basically go line by line, instruction by instruction in like EVM low level opcodes. And there's also a way how you can like find some problems in, for example, this low level debugging is great for some storage like memory stuff, if the memory really do what is intended to do. So if I can just summarize like the flow, the steps, it's basically understanding the protocol with documentation, then auditing line by line, and then move to like more using tools and testing and writing fast tests. And if we do like all these stuff together, then we can be like pretty confident about our output.
Great. And so what was the output? What were the findings?
Maybe Mira can say some things about some issues we found.
Okay, so when I was thinking about what issues should be discussed here, I thought that it would be great to mention some issues that would generalize well and that the audience could use like in their products and in their smart contracts. So no issues that are like directly connected to the IPOR protocol, but that can be found in the wild. So one of the issues that we found was using like the ownable pattern, which means that you have a contract and there is some privileged address that can do some important transactions and change the state of the contract in a way that others can't. And for transferring ownership, you usually want to employ a two-step process. That is, you propose a new owner, and this new owner is supposed to accept this ownership. This is good because if you propose a wrong owner, you don't lose the ownership, you just propose a new one. However, there is a pitfall in this process, and we found this issue also in the code, and that is if you propose new owner, and in the meantime and the new owner doesn't accept the ownership, and you in the meantime renounce the ownership, then in such case no one ever should own the contract in the future. Like if you renounce ownership, the ownership goes to address 0 and that's it. However, there was a problem in the code that when renouncing the ownership, the proposed owner wasn't cleared, and thus in the future the proposed owner could accept the ownership and gain the ownership of the contract even though it was renounced. So this is a generally a rather common issue that I've seen multiple times, but it's tricky to spot. So I thought that it would be great to mention. Also, using like L1s can be pretty expensive, so I thought that it would be nice to mention some gas optimization tips that could the audience employ in their contracts. I will just mention them quickly. So that is use post increment over pre increment. Oh, sorry, the other way around. In your for loops. So in the for loops, in the for loop header, the semantics is the same. However, post incrementation costs more gas. So another tip is to not to declare variables inside loops, because they get recreated for each iteration. So it's a good idea to declare them outside. That also leads to some gas savings. And the third tip that we also discovered in the code was usage of memory for arguments over call data. So in certain cases, you can leave the arguments in call data. You don't need to copy them to memory. And by omitting this copy, you again save some gas. So do not default to using memory for arguments. Try to use call data, and this will lead to some gas savings. The last thing that I'd like to mention is contract composition, and that we propose this special way for composing contracts of your own protocol that is not error prone. So this is issue about data validation, and we propose a new way how to avoid passing wrong addresses to our contracts. So let's say that you want to compose your contract A and contract B, and that you want to use the address of B in A. So in this case, you would create an identifier in the B contract that would be, for example, a constant saying like I'm a B contract. And when you pass the B's address to A, in A, you would call the constant and verify that the output of this call matches the expected value. And then by using those constants, you can easily validate that the contract composition is okay. And again, this brings almost no gas overhead, because like constants are pretty cheap, and there's one additional call in the constructor. So this is a tip how to compose contracts in your protocols, which is very safe and very cheap. And now I will hand it to Lukáš.
Okay, so I think we can mention the issue in the mathematical ABDK library we found. Basically, IPOR Protocol are using these high precision library for computing the rewards, and the library is called quadruple float, which means is the extension of the normal double float, which we know from other languages. And we've like we've if we see some mathematical function, it's like the ideal spot for use and fastest, and it's like easy way how to make sure that all these mathematical operation works as expected. So for this case, we use like differential fast testing, but this fancy words basically means that we use the smart contract of the library, and at the same time we perform the same operation on the Python package, which is called Big Float. Big Float is basically like the implementation of the well-known C library, which is called MPFR, I guess. And so we like randomize the inputs to the mathematical functions. There were like 4 functions for adding, for multiplication, and for logarithm. And we like run these tests on the randomized number of operation. The order of operation was also like randomized, and we find that there is the output is not matching in all the cases. So we like start debugging what's the cause, like what's the cause of the issue, where does it came from, and we find out that the logarithm function in this ABDK library is giving us wrong inputs in some more edge case scenarios. And more like correctly, the problem was that if we use this logarithm function, we lose some precision. And this precision was not matching with the output from the Python Big Float library. So we found this issue, and we tried to like find some exploit for the IPOR protocol, but because like the loss of precision was like on a very small number, so it doesn't affect the IPOR like reward computing and reward distribution. But we decided to report it, and we also like reported to the ABDK team. But the response from the team was like that this loss of precision is somehow expected, and if they want to implement like the more precise function, it will cost more gas, and it's not like intended. But we find it like pretty cool issue because like the ABDK mathematical libraries are very well known and widely used, and in this case it doesn't affect the protocol, but in some cases if the like mathematical operation inside of IPOR protocol like were made a different way, it can be a problem and it can lead to some locked tokens and similar unpleasant stuff.
Yeah, this is a very curious issue. IPOR guys, do you have anything to add about the issues?
Yeah, so I like to comment on this particular issue and how it was discovered. So I actually like the way you guys handled it because when you found it, you reach out to us, say, first of all, like you reach out very quickly and say, hey, we found this issue with this library. You described it and ask us like, what do you think? And because we understand also what we're trying to solve for, then we basically said that's okay. In what we're using it for, it doesn't matter if we have in this edge case there is some imprecision because because of the nature of like how we use it. So it doesn't really matter. Like we can be even more off, and it won't change much. But what your guys said, I will forget it was Łukasz or Miroslav or even Stefan, I forget. But I remember you guys said, like, listen, we know that there's other protocols using this. So before you announced, we announced this, in audit, let us reach out to, those teams and just let them know that there is this error. So just don't announce your audit report if you don't have to right now. So we have time to go to those teams and let them know that this issue. And I think this is very good and from a community perspective, because what we're trying to build here is, is the future of DeFi, and there's many protocols, doing whatever they can to deliver the best products possible. So we're in the same boat. So if we find something in the library that some other protocols are using, let's let them know. Let's be let's play as a team here. I thought that was very nice process to handle that, because in our case it didn't matter, but in some other protocols, I can easily imagine that this could have serious consequences. Now, there was also another bug that we found, and I like the way it was handled. So that was a bug that we found at the IPOR labs after the audit. So again, this was related to something that somebody tweeted about, and our IPOR intern kind of passed it on. And our engineers look at it and say, hey, maybe we suffer from similar issue. So we analyzed our code, and we thought, well, there is an edge case where, there could be an issue. So the first thing we did, we reached out to you guys and say, hey, can you guys confirm that? And this is already, like, we're talking, like, this is handling IPOR after audit. So, this is important. So this is service after. And the guys immediately jumped on it, and we verify, in what situation this can actually happen. There was a re-audit, which you guys did, complimentary, which was very nice. And we issued a, second version of report. The issue was patched immediately. And I guess this is another thing. Going back to the previous question, what makes a successful audit? We accept that there's the things might slip through. Like, we look at Euler, they extremely good product, extremely good team, the best care, and there's things that they can go through, but it's like how we maintain the product. Like, we keep on looking for issues, and we collaborate. So I really feel like Ackee is a partner here. So that was very nice. To be able to keep on working even after the first audit was already done. We were very happy with it. We keep on looking at what can be improved and what other risks there are. So I would say that how do you call this? Out of warranty? No, it's not out of warranty. It's like this after sales kind of collaboration. I would say it's really good, and we definitely are looking forward to more audits with Ackee. So yeah, on to you.
Thank you. I think I can speak on behalf of the whole team that the team really enjoyed working with you too. Yeah, so I think that probably it's time to ask our listeners if they have any questions. Just don't hesitate to raise your hand, and we'll invite you to speak. Don't be shy. Okay, no volunteers.
I actually have maybe a question related to Euler finance, and Lucas just mentioned that. So I'm curious to learn if you guys have looked into it and like figured out what caused it, and how can this be prevented, or is it some issue that is widespread? Is it something very specific to Euler? Yeah, anything. If you have had time to actually look into this.
Yeah, so this is a good question. We actually had an audit last week with Gnosis, and it was a really important audit, and we didn't yet have time to study the exploit in detail. So I hesitate to provide like any commentaries regarding this. I don't know if Lukasz studied it a bit more, but we both worked on the audit, so I'm sorry, but we don't have like any good insider information yet.
All right, that's fine. I was just wondering. Thank you.
Okay, so no further questions. Yeah, okay, so I guess probably it's time to say thanks to our co-hosts, to our speakers, to IPOR team, to Ackee team, and to all the listeners who were here with us.
Yeah, thank you very much. Thank you for coming.
And on behalf of IPOR, and IPOR Engineering especially, I'd like to thank you guys for having a very good collaboration so far, and I'll definitely recommend Ackee to other teams. We will definitely keep going with other other contracts that we develop. So yeah, good stuff. Thanks Miroslav, thanks Lukasz. We are very happy with you guys, especially that you really try to understand what we're doing, and there is more complex things. So having
Yeah, it's interrupted.
Yeah, let's cut off.
Yeah, we remember there are more complex things. So I guess he was about to say that we'll stay in touch.
I prematurely hit the mute button. It's my fault.
I would like to say thank you for your kind words. And
so we actually figure out how to make this work, even though I cannot connect. So for those who are late, we're actually running this. I don't know, maybe that's why the audio quality may suffer. But we're running this Twitter space, so I'm connecting through Darren's Slack, and then he puts the microphone next to his computer. So technology. You fight with technology every day.
Yeah, but it's nice that we found a way out.
Sometimes it's not.
Okay,
I think
guys.
Scrabmere wanted to say something or not.
yeah, I just wanted to say that we thank for your kind words, and from like the auditor's perspective, we extremely enjoyed working on the protocol because it had some challenging ideas, and it was like more complicated than the project so we normally audit, and it was really fun. We are also like computer scientists, so working on the details of implementation of like quadruple floats was so much fun. So we are looking for future collaboration.
Yeah, the same for me, guys. It was great.
From the especially the calls that we had, we can tell that you guys are curious in this very positive way. So this is great. Yeah. Cool.
I actually like.
If I can just add one more word, it's not like just kind of another assignment, but you have this spirit of collaboration. So yeah.
Lukash, you were saying something.
Yeah, I just want to say that I'm like, since this like audit, I keep dreaming about the diagram you provided us, because like for the audience, it was like the diagram where you can see like the contracts and how they work together, or how token transfers work. And if you have something like this to visualize the protocol, it extremely helpful. And since like this audit, I'm requesting our all clients if they like maybe create some diagram like this for us, because it was like super unique and very helpful. So again, like, good job and thanks again.
Yeah, you set a high mark. Okay, so thanks everyone. Thanks again to the Ackee team, to IPOR team, and to all the listeners. And have a very good day, evening, morning, whatever. Talk to you soon.
Goodbye.
Thank you, guys.
Bye-bye.
Bye bye.
Bye.
Thank you. Bye bye.